Hello, guys. Good evening. I hope everyone is doing good today. And I feel happier and I feel really motivated to bring you this knowledgeable content to you. Not just because it is getting streamed in our channel, but we are doing it out of passion. And as you already know, these are compilation of data engineering questions asked across the interviews, and it is not just mine, but this is also a combination of knowledge from my friends who have been appearing for the data engineering interviews as well. So I hope that you all make most out of this video lesson. And before we jump to the video today, which is going to be about the data engineering series, and this is the part number 17 of it, right? And before we jump to the video, I would like to introduce about our company. We are Data Valley, the fastest growing edtech company of 2025. And if you're wondering what do we offer as a company, how can we help to your growth, then I can say that we provide you with IT solutions, trainings, and placement support. So, what do I mean by IT solutions? So, for example, let's say you need to uh, no, you need to hire talented professionals for your company, and then we can say that yes, we have talented skilled people in our company who can take over your business requirement from day one itself. So that is the support for our IT solutions. And if you're just asking me if that is all that we have, no, we do have trainings and placement support as well. What do I mean by training? So yes, we are established MNC company, but still, as a part of our organization, we have training institute just in the case that we would like to train people in demand and industry requirement uh, education, because there are a lot of institutes in place, but they do not teach what's in demand. They do not teach what is practical. They do not teach what is in reality. They are just like, they just teach the basics, few syntax, and done. But in real life it doesn't work that way, and that is where we come. We provide you trainings, and our trainings are in multiple modes. And if you're wondering what subjects do we teach, we have data engineering, analytics, data science, cybersecurity, ethical hacking, web stack developer, MERN stack developer, UI/UX designing, ethical hacking, cybersecurity, SQL developer, Python developer, software engineer, whatnot, whatever is in demand right now in the industry. Yes, you can be very sure that that is going to be taught in our institute. And your trainings also come with the 100% placement assistance. So once you have enrolled to our company, you can be very assured that you'll be getting placement support as well. And today, myself, Franklin, I'll be taking this interview series with you. And I've almost got 3+ years of experience as a data engineer. And I believe this session is going to be very useful to you. And you all know the routine, what you have to do, isn't it? So if you have the habit of drinking coffee, have your coffee, because you might be just back from your work, your college. So if you take a coffee, you'll feel kind of fresh. And if you have the habit of taking notes, have your notepad ready. And whenever you have questions, feel free to drop it in the comment section and I will address them for sure. And also feel free to give a thumbs up and click the bell icon so that you don't miss out on the regular updates from our channel. Fine. So, in this data engineering series part 17, what are we covering today? We are covering the AWS Glue. So, you might be wondering, isn't that we have been learning for a long term? Yes, I think since part number 11, we have been learning AWS Glue. So, how is it different and what is the difference we are making today? So, the key difference is that your AWS Glue, it's a complete ETL service from AWS Cloud. And if you have to talk in detail, it's not something you learn in one day. You need to put in efforts. You need to understand, what is what, how things gets done, what is the functionality of different components. And if you have seen our track record, we started with the basic fundamentals of Glue, about its components, etc. And then we learned about how to design, how to implement the design, and now we are at the stage that where we are discussing about the performance, and in the future we'll be even discussing about the optimizations as well. So today it is going to be the third video for our performance. And just to ensure, as a disclaimer, this is a standalone video. It's not necessary that you have to learn from the first part and then come to this so that it'll make sense to you. No, it doesn't work that way. This is a standalone video, so you can entirely learn from this part itself. But personally, I would recommend, once you finish this video, go and have a look on the previous videos so that you are having a good edge on your AWS Glue technology. Okay, because we are discussing practical scenarios and how do you handle it, how do you manage those kind of use cases. So it'll be very beneficial to you. Okay, now to our video. The first question that I have is, how do you handle incremental data loads with AWS Glue? So we can split the question into two. So first you have incremental data loads. Okay, so you are having incremental data load. So what is incremental data? Yes, I'll show that with a diagrammatic explanation. But incremental data, okay, and this is very common in a data engineering domain. And how are you going to handle with the AWS Glue? Okay, fine. First, let's see what is an incremental data. So as you can see here in this picture, I've got a nice data source, and next, like Thursday, Friday, Saturday, and Sunday. But I'll explain that. So in here I have my full data source. Okay, this is my first data source, and this is going to have all my previous data. Okay, so today is Wednesday, so I'm going to have all the data from uh, from whatever the day I've started storing the data into my data storage. So this is my entire data set, all my files inclusive of it. And now, first thing what I do is, if I'm trying to migrate my data, or if I'm trying to load my data to a different warehouse, let's say, okay, so I would do a batch processing, right? So I have my data source here. I'll be just replicating, or either I'll be just transferring all the data from this to my full backup. So this is my batch processing, and this batch processing will have all the data as similar to your data source. I hope that is very clear and very basic. And now this is where your incremental data comes into play. So let's say I'm getting new data for my Friday, right? Because each day, let's say you have your retail store, you're going to have transactions for each day. So how are you going to handle it? So in this case, from the first source, you have additional data of your Friday, and then you have your incremental backup for the next day, Saturday, and then you have further incremental data that is for your Sunday. So on top of your original or fully migrated batch process data, you have additional data coming in for each of the day. So by definition, the incremental data is the new data or the updated data that is been in your data storage or in your database. And how do you handle this incremental data is very, very crucial. There are different reasons why this is crucial, because it serves as a important component for your business use case scenario. And you as a client, or you as a provider, you don't want to miss out on the customer's information, you don't want to miss out on the product analytics, you don't want to miss out on the marketing campaigns, you don't want to miss out on the product inventory analytics. So all these kind of reporting or analytics, or data science related tasks, what plays a major role is your data. So whatever your data that is coming for each day, those must be handled in a way that you don't miss out on the pattern of learning from your data. So how do you process your incremental data from day one? Okay, batch processing is easy. You just define all your source and target, and you can process it. But with the incremental data, it comes with many problems. For example, let's say this first backup is having like files 1 to 10. and now I'm having a new data coming. Let's say this has a file called file number 11. So when I'm trying to do incremental data, instead of processing all the data, okay, so 1 2 3 4 5 6 7 8 9 10 and 11. So this is 11 file type, 11 files, and we are going to waste our processing, right? Because it is inefficient if I'm processing all the data that is existent. But it would be very efficient if I just process only the new incoming data or new updated data. So let's see what are the strategies we have in place to handle this kind of scenario. Handling incremental data loads with AWS Glue primarily involves using AWS Glue job bookmarks and strategically designing your ETL jobs. So one benefit or one best feature of using AWS Glue is that you can try to use a feature called as AWS Glue job bookmarks. We will learn about it, but just know that if you have to handle all your incremental data at ease, Glue provides this feature which you can avail, and this is going to benefit your incremental data load as well. And now let's talk in detail about our AWS Glue job bookmarks. Job bookmarks track the state of previously processed data, allowing Glue to identify and process only new or changed data in subsequent runs. So, what happens when you use job bookmarks is that any data that has been previously processed, okay, that will not be taken into account. Any data that has been having a change or an update or a new insert, only these new data will be processed. So in case if it is a file, it will be processing a new file, and if it is a database, it is going to process you only your new data that is in your database. Okay, so job bookmarks will help you to only process the new data and leaving the previously processed data. And Glue has this ability to identify and process these data in the subsequent runs by the feature called Glue Job Bookmarks. And now let's see how it works. For S3 source, it's different, and for relational database, it's kind of different. Let's say you have S3 as your source. So what is S3? S3 is nothing but a simple storage service, right? So if you're having a simple storage service, how are you planning to process it? What is the step you have in place to process all your data? And talking about S3, it's like a data lake, and where you might have lot of files coming and getting dumped each time of your day. So it is very important and necessary that you handle this incremental data in an proper and efficient way. Okay. So what happens when you set S3 as the source and you enable Glue job bookmarks? So what happens at this time is that whenever the new files comes into your S3, your Glue will able to identify the last modified time of the S3 objects. So whatever files that is in S3, you call it as objects, right? So whatever your S3 objects are, it will try to use the last modified time to determine which file is new and which file has been updated. Okay, so based on the modified time, you will be able to process your incremental data. And what is the scenario if you set Glue job bookmarks for your relational databases? So if you're using a relational database, you will have a designated feature called as job bookmark key. Okay, so this job bookmark key, okay, is nothing but it's a primary key in our incremental or the decremental column. Okay, so for the particular incremental or an decremental column, your primary key will act as an job bookmark key, which will help you to identify the new and the changed records. Therefore, you will be able to process the updated or new data in your relational databases. All right. So for different sources, your glue job bookmarks will function in a different way. Cool. How do you enable it? Yes, I want to use glue job bookmarks, and how do I enable it? So to enable glue job bookmarks, you have an option called as advanced properties under your AWS Glue ETL job. So let's say you already have your AWS Glue job defined. You have an ETL in place. Okay. So if you want to enable the glue job bookmark, okay, or let's say you want to enable the incremental, you want to handle your incremental data, all you can do is go to the tab called advanced properties. Under the advanced properties, you have an option called as enable job bookmarks. And when you enable the job bookmarks, you will be able to you know uh, set your glue job bookmarks, which is going to handle only the incremental data. So whatever the data that has been previously processed will not be taken into account. Only whenever the new data comes into your S3 bucket or in your relational database, only those particular data will be handled. Okay, let's say I have enabled it, and how do I reset it now? It's very simple. As you have enabled it, it's pretty much the same. So what we can do is we can reset all our job bookmarks by just disabling the glue job bookmark feature. Okay. So if you need to reprocess all the data, so why do you need to actually disable the job bookmark? You will be doing that only if you need to process all your old data, right? Because see, let's consider this. You have files 1 to 5 already in place, and now you are enabling job bookmarks. So anything after number 5, so your files from 6, 7, 8, 9, 10, whatever the new files will get processed. And let's say you're processed till 10th, and now I'm resetting. So what do I mean by resetting here? I'm disabling the job bookmark. So what happens when a new files like 11 and 12 falls into my S3? All my data, okay, including file number 1 to 10 and 11 and 12, so total 12 files will be processed in one go. Okay, this is the process of reprocessing all the data. And also you can reset the glue job bookmarks by resetting the job bookmark API or via your AWS CLI. Okay, now how do you design the ETL job for your incremental loads? First things first, try to identify your incremental source. So you have to know your source so that you can deal with your ETL job in a better way. So determine how your new data falls. Okay, either either it is an file format, either it is a file type in your S3, or is it a new records that is being added to your database. Okay, so either it is a new file type or either it is a record in your database. So define what is your incremental source, and then now you have to configure your glue jobs. How are you going to configure? First, set your source. So all you have to do is point your glue job to the incremental data source, example an S3 path or a database table. So yes, I know where my data is going to be arriving, and now I want to configure my glue job. Therefore I am pointing my glue job to the data source, so either S3 buckets or a database. And then I have to enable my job bookmarks, right? So all you gotta do is enable and configure the job bookmark as described above. So we just learned about enabling the job bookmark, isn't it? All you have to do is go under your advanced properties and then set your glue job bookmarks. So once you enable it, then you can set your transformations. Implement transformations. Okay, sorry about it. Implement transformations to process only the incremental data. This might involve joins with existing data for updates or simple insertions for new records. Okay, now we have defined your source, now we have enabled the job bookmarks. And the next step is you're going to implement the transformations only to the new incremental data. And how are you planning to do that? So you are implementing transformations to process only the incremental data, and this involves uh, joins with the existing data for updates or simple insertions for new records. So what do I mean by joins with existing data? Let's say you are already having a few data sets, okay, maybe the batch process data or the previously enabled incremental data, whatever that is. So the first thing that you have to do is you have to enable, and you'll be performing the joins, right? So this will involve joins where where you will be comparing to your existing data for the updates. Okay, so while you try to do your joins with the existing data, and then for updates, so why do you have to join with your existing data? To check if there are any updates, right? So we have concepts like merge into, we have upset logic. So we have different kinds of strategies to handle with the incremental data in our data warehouse or our data sets. Okay, sorry, data in the database. But we'll talk that in a different video. But what I'm trying to tell is you compare it to your previous data, and then by comparison you will be checking what data has been updated, or let's say there is no modifications or no updates. And then what you do is if there are new insertions, okay, if there is new data that is being taken to your the data set that you're processing, then what you can do is you can just process your transformation in a way that you add the new data to your loading target. Now define the target location where the processed incremental data should be loaded. Example, a data warehouse like Redshift, another S3 location. So, as you have defined your source for your incremental data, and after you finish your transformation, it is also necessary that you process your that you define your target as well. Okay. So, what do I mean by a target? So, the target location is where the processed incremental data should be loaded. And if you're wondering, is that necessary that it should be only in your AWS environment? No, it is not. So whatever your data is, you can just load it and to a multiple sources, even to an external data warehouses like Snowflake. It can be another Databricks. So it doesn't matter. It can be a data. So as long as you can connect with them, as long as they are JDBC compliant enough to connect with your glue, then you are completely fine. And by this strategy you can enable your ETL job with incremental load. Then optionally you can schedule as well. But if you ask as a data engineer's perspective, yes, I would recommend you scheduling because it comes under the part of your automation. So you don't want to be running your ETL job daily, isn't it? So I mean daily in a manual fashion. So if you need to process your data, it is better to schedule the job and you just process it appropriately by setting intervals. So the intervals can be hourly basis, it can be hourly, it can be once in 6 hours, once in 12 hours, or it can be a daily interval or a monthly interval. So it's all up to you, okay? But it's good to schedule in a way that you will be automating your ETL pipeline. So by scheduling also you are managing only to process your incremental data. Considerations for specific sources. For S3, ensure that the data is organized in a way that that facilitates incremental processing. So what are we trying to say here is that yes, we have defined sources, right? We learned about two sources. Is it an S3 source where the new file types comes into the loading bay, or is it a database where your data will be frequently changing, which means an update, or you might have new insertion as well. So these are the two different sources that we really need to pay attention towards. So if it is an S3 bucket, if your S3 bucket is the source, what you have to do is you have to organize your data in a way that the incremental data processing can be achieved at ease. So what you can do, all you can do is simple, just categorize your folders based on the date. Okay, so you're going to enable date partition folder. So how can you achieve that? So you can split the folder into, so whatever the project that is, then based on the year, then you can split it into month, and then further the month can be put in as date. Okay, so you will be having an hierarchy where your data will be getting loaded, and then you will be able to process the data in an easy way. And then databases, choose a suitable job bookmarking that guarantees monotonic changes to accurate incremental identification. So for databases, it is very crucial that you select job bookmark key, right? Which is a key from your incremental or decremental column. So once you fix that, you know, uh, once you select the appropriate bookmark key, you can set your database for an incremental load. Therefore, it is very efficient. And then also you have a strategy called CDC. So for complex scenarios involving deletes or granular updates in databases, consider using AWS Database Migration Service for CDC to capture these changes before processing with Glue. So what you're doing is, so when you have complex scenarios, okay, like a delete or a granular update in databases, we can consider to use AWS Database Migration Service (DMS), okay, for CDC. So what do I mean by CDC? CDC is nothing but change data capture. So that is just an abbreviation, but by definition, as the name suggests, you are capturing the data that is getting changed. I hope it makes sense to you, right? So you are just going to change the data. Sorry, you are going to capture the data that is getting changed. So whenever you have too much of frequent changes in your data, one easy thing that you can do is you can enable CDC, and then once you enable the CDC, you can use DMS, okay, database migration service, to capture the data from the source and then process it incrementally. So by leveraging all these features like AWS Glue job bookmarks and carefully designing your ETL job and defining your proper data source and your proper incremental target, you can minimize your processing time and resource consumption. So these are the few things that you can do to handle your incremental data in your AWS Glue. Okay, fine. And sorry. And to our next question. Discuss techniques for optimizing data partitioning and file formats for AWS Glue jobs. So, what are the techniques that we have to optimize our data partitioning and file format for our AWS Glue job? So, what do I mean by data partitioning? So, partition. So, you know what is a partition, right? You split or you separate the data. So, how are you going to do that? So, what strategy do you have to optimize the data partitioning? Okay. So, what you can do is you can optimize your data partitioning by using the efficient column that has low cardinality. Let's say I have a data set and there is a column like let's say region, and for region I have four which are north, south, east and west. So because I have four columns in there, sorry, because I have four cardinalities within a column, what I can do is I can select my region as a partition by which my file will be partitioned into 4 files. I hope that makes sense to you. So let's say I have 1 GB size of file, and to my 1 GB file size, what I'll do is I'll partition it based on the region. And by doing that, what I'm doing is I'm splitting my data or partitioning my data into four with 450 MB approximately for each of the file. So if you see in here, I've got a big table. I've got big one table, and to this table I want to partition it, and I'm partitioning it based on the month. Okay, so for the year 2019 and May, this is one partition of data, and for June 2019 this is one partition of data, and July 2019 this is one partition of data. So my single data, my single big table, is getting split into three separate files. Okay, and therefore when I want to process the data, I can efficiently just choose this particular partition data, and then I can process my entire data. So this is the concept of partitioning. Now let's see how to partition our data, partitioning and file format. Optimizing data partitioning and file formats are crucial techniques for enhancing the performance and cost efficiency of AWS Glue jobs. So, if you want to optimize your data partition, okay, and to optimize your file formats, there are certain techniques which you must take into consideration to enhance the performance and cost of your AWS Glue job. First, data partitioning technique. And under data partitioning technique, the first thing that we are going to discuss is hive style partitioning. So, what do I mean by hive style partitioning? Let's say you want to organize your data in S3. Okay, so how you can organize your data, which we earlier even learned in our incremental data loading. So, what you can do is for your data, you can try to structure it hierarchically in a way that, so for example, first your data gets put into a bucket, which you will be further splitting them into year, and for each year you will be splitting your bucket into 12 months, and for each of your 12 months you'll be splitting your data into different buckets considering the day. So you might have 28 to 31 buckets per month, right? It differs depending on the number of days in a month. So if you set your data partitioning in an hierarchical fashion, therefore you are allowing your glue job and your querying tool, which is nothing but Athena, right? Athena is an interactive query tool. So you can use those to prune only the relevant partitions. So what you're doing, so let's say you want to process the data only for 16th of September, which is yesterday. So instead of scanning or analyzing all the data from all your previous dates, and because you have partitioned your data based on the date, so you get to process only the data from yesterday by using your hierarchical structuring. Therefore, you are reducing the amount of data getting scanned. And of next, you have predicate pushdown. So when reading data into an AWS Glue dynamic frame, use partition predicates in the filter clause or when creating the dynamic frame. So what happens is that we just saw that we are splitting the data in a hierarchical fashion. And that is a very clear concept, isn't it? Let's say you want to access the data from 16th of September. You just search for the year 2025, go to the month September, and within the September, you will be able to find the date 16, and boom, you'll be having your files. So, what you can do with your predicate pushdown is that, so you can use partition predicates in the filter clause. So, what happens now is that now whatever the data that is, okay, So you will be able to filter it. You will be able to push the filters and the logic, and because you're filtering from your data source, you're preventing the load of unnecessary data into memory. So you're not processing the unnecessary data by pushing your filter early to your data source, which is nothing but you're selecting only the necessary data and leaving out the unnecessary column or the data. Next, you have Spark partitioning with repartition and Qualys. So this is one important strategy, I must say. So within an, why are we even talking about Spark partitioning here? Because under the hood of AWS Glue, you have Spark architecture, right? It is not different to your Spark architecture. So under the Glue as well, you have the same Spark architecture, and it is no surprise that we are using the optimization strategies of Spark architecture. So in here we are going to discuss two things, which are Qualys and repartition. So both for your dynamic frame or your data frame, these play an important role because these are the ones that control your number of partitions. All right. Okay. Now let's talk about the repartition first. Repartition distributes the data across a specific number of partitions. Okay. Repartition distributes the data across a specific number of partitions or based on specific columns, ensuring even data distribution for parallel processing. This can involve a data shuffle. So what you do is when you set your repartition, and in the bracket you put in a value. Okay. So for example, you want 10 partitions. Okay. So what you do with repartition, you just specify the number 10. And now what happens is that you'll be having 10 data partitions, and all your data will be equally split across all these partitions. So you'll be having even data distribution, and by which you'll be able to attain your parallel processing as well. And one drawback of using repartition is that yes, it has its own benefits because you can decrease your partition number. Yes, I understand. But there is also a drawback where you need to perform a lot of data shuffling. Then you have Qualys, and Qualys is a functionality where you can just only reduce the number of partition. Okay, so you're not increasing it. You can only decrease the number of partition without a full shuffle, which is more efficient when simply reducing parallelism. And if you're asking which is better, the repartition or Qualys, I will say that go for Qualys only when you're reducing the data. Okay, if you have to reduce the data, reduce the partition, don't go for repartition because repartition will have data shuffle. But if you use Qualys, you can reduce the number of partitions without any data shuffling or very negligible or reduced data shuffling. Then you have job bookmarks. For incremental processing, enable AWS Glue job bookmarks to track processed data, ensuring only new or changed data is processed in subsequent runs. This implicitly acts as a form of partitioning by processing only a subset of the data. So we already learned about the glue job bookmarks, isn't it? So when you enable job glue bookmarks, you're not going to process all the data, but only the data where there has been a change. So you're just processing the incremental data, in other words. And also, if you enable job bookmarks, this is going to act as a partition as well. How come? Because your files or your data that has been modified will be kept separate, isn't it? So your system will know that after the particular time all the data that has been arriving are new, and therefore you can process it in an efficient way. And then you have file format optimization. For file format optimization, here are the few things that we are going to discuss. First, what is the format of your data? So talking about the format of data, you have row format and you have your columnar format. And for your columnar format, what you can do is, uh, it, uh, okay, let's talk about the row based. In row based, you have CSV, JSON, XML. So these are the row based data. And for your columnar based data, you have Parquet, ORC, Avro. Sorry, Avro isn't row based, but you have Parquet and ORC. ORC is nothing but optimized row columnar data format. A widely used columnar storage format that offers excellent compression and encoding schemes, making it efficient for analytical queries as it only reads necessary columns. So, what happens in your column based data is all your data gets stored in its columnar format, which is very useful when you are trying to process large amount of data. Let's say you're choosing particular columns to be processed. So instead of going across through all your data sets row by row, you're just selecting the columnar data. Therefore, the performance is very faster, and also you will be having excellent processing speed as well. So you're leaving out the unnecessary columns. And then you have ORC, another columnar format with similar benefits to Parquet, often offering slightly better compression and query performance in some scenarios. So, if you're asking me personally if I would prefer Parquet or ORC, I would always say Parquet because Parquet, offers us with better compression. So you can use Snappy or GZip. I mean, I wouldn't recommend GZip anyway, but Snappy along with Parquet is the best format and compression you can have in your place. Benefits: columnar formats slightly reduce input-output operations and improve query performance by allowing predicate pushdown at the file level and efficient data retrieval for specific columns. So when you need to process a certain data, okay, so instead of doing full table scan, you can use your columnar format with which comes with the benefits such as predicate pushdown at the file level, and therefore you can efficiently retrieve your data for your particular column. And then compression: apply compression algorithms like Snappy or GSnip or zstandard to your chosen file format. Compression reduces storage costs and input output transfer times, though it adds a slight CPU overhead for compression decompression. Snappy is often preferred to for its balance of compression ratio and performance. Yes, you're using an efficient data format. Fine, agreeable. But even for your particular columnar format, what you have to do is you have to use an efficient strategy. You have to use an efficient compression algorithm, which are nothing but your Snappy and your GSnip. And for your Parquet, especially go with Snappy because it gives you better compression ratio and performance. So if you need to balance between these, go for Snappy. And then you have small file handling. What do I mean by small file handling? So avoid generating an excessive number of small files, as this can lead to performance bottlenecks due to increased metadata operations and reduced parallelism. Consolidate small files into larger ones during the ETL process. So see, it's very common, right? It's a very common scenario where you are going to have a larger number of smaller files getting dumped. So what do I mean by smaller files? For example, sometime you might get an 1 MB file, 2 MB file, 5 MB file. So each time you're going to access your data from S3, you're giving too much of S3 request in first place, and then also you're troubling your performance as well. And let's say you have larger number of executors in place, and if you're just processing 1 MB file with all the executors in place, then you're being very inefficient in your work strategy. So what you can do is you can try to get all these data together. Okay, you can try to increase your metadata operation and reduced parallelism, okay, by combining all these smaller files. You can merge all these smaller files, and then you can process the larger ones using your ETL process easily. Then you have data serialization libraries. So the better one is CERDES, okay, like which stands for like serialization and deserialization. So always go for the appropriate CERDES for your data format in the AWS Glue data catalog. For example, use the Parquet SERDE for Parquet files. This ensures efficient serialization and deserialization of data during the glue job execution. So when you are processing your data, okay, so try to use a better serialization and deserialization, and therefore you'll be able to process your data efficiently. So these are the few strategies we need to keep in mind to optimize our data partitioning and file formats. And then, what are the best practices for structuring data in Amazon S3 for optimal performance when consumed by AWS Glue jobs? And we are going to discuss in the aspect of data partitioning, file format, and compression. Let's try to understand the question better. You're going to put your data in S3. It's very obvious. So, how are you going to structure your data? So when your data falls in, you need to have a structure in place. When you have a structure, your process becomes very efficient. So what you'll do is you're going to have an efficient structure, and from that particular structure, you're going to have an optimal performance as well. So let's now discuss about the partitioning, the file format, and the compression aspects of data structure. So if you see here, I've just given an a representation. You have an S3 data lake, and from which you will be processing your data using your AWS Glue data crawler, which you will be further using the data for your AWS Glue. So this is just an representation. Fine. Structuring data in Amazon S3 for optimal performance with AWS Glue jobs involves strategic choices in partitioning, file formats, and compression. The first thing that we are going to discuss is the partitioning. So for partitioning, what you can do is you can use hierarchical partitioning. We already learned about the hierarchical partitioning, right? So what is the hierarchy, usual hierarchy that we have? It's the year, month, and date. So that is the one example for your hierarchical partitioning. For in other, you might have other use case scenarios for your business, and depending on that, you can set your different kind of structuring as well. So in hierarchical partitioning, it plays like an logical hierarchy, right? And it is based on the frequently queried dimensions. So we are going to always use the latest kind of information, and for that you can have the logical time based hierarchy. And this is going to allow AWS Glue to prune unnecessary partitions, reducing the amount of data getting scanned. So you're leaving out on the data that you don't want, and you're scanning only the data where your particular column makes sense. So based on your partition. Granularity. Choose a partitioning, sorry about this. Choose a partitioning granularity that balances the number of partitions with the size of the data within each partition. So you are going to have a partitioning granularity which is going to balance the number of partitions. So what do I mean by the granularity and the number of partitions? So depending on the size of my data, I can set the partition, and from which I'll be able to choose my partitioned granularity. So too much small partitions can lead to overhead, while too few large partitions can negate the benefits of pruning. So as I said earlier, if you remember, when you choose a partition column, make sure that it has low cardinality. And why is that? And it is not just that low cardinality. For example, if you're having like 10 partitions for a column, or a 10 cardinality for your column, that is perfectly fine. But what if you're going to have, like let's say your date column can never be a partition, right? Why? What do I mean by that? Or I mean, yes, time can be at some times when you're having large number of data sets. But what if you're having a smaller data and you're having a date as your partition? Then that is very inefficient, right? Because if you consider for a smaller data set, so each day you'll be having just like 1 MB or 2 MB file. So it is very inefficient strategy. So depending on your business use case and the partition along with the cardinality, choose the better one. And then metadata catalog. Ensure, okay, sorry. Ensure partitions are correctly registered in the AWS Glue data catalog for efficient discovery and utilization by AWS Glue jobs. So whatever the data that we have, whatever the file that comes into S3, make sure that your Glue crawler, crawls through your data, and your Glue data catalog, which is nothing but a metadata repository which stores your schema information and all you know, your table definition, the data definition. Make sure that you set that in place so that your data and its schema can be discovered and can be utilized by your Glue job. Okay, therefore you'll be having a better understanding of your data. And then you have file format, which we have already discussed, but we'll be discussing a bit more in depth now. Columnar format. Prioritize columnar formats like Parquet or ORC. These formats store data by column, enabling efficient predicate pushdown, filtering at the storage layer, and optimized input and output operation by only reading necessary columns. So what you're going to do is you're going to prioritize the columnar format like Parquet and ORC, because your row-based your row-based formats are not an efficient strategy, especially if you need the benefits of partitioning, the predicate pushdown, or partition pruning. So what you can do is you can try to use a columnar data format, including Parquet or ORC. And personally, as a data engineer, I would recommend you to use Parquet file format. These formats store data by column, enabling efficient predicate pushdown, filtering at the storage layer, and optimized input-output operation by only reading necessary column. By having an efficient file format like columnar, you're not going to do full table scan, or you're going to scan the unnecessary data. Because while working on the data, you'll be scanning only the necessary data, isn't it? So to scan that, yes, set the efficient strategy so that you can save out on the performance and efficient processing. Splittable formats. Ensure chosen formats are splittable, allowing AWS Glue to parallelize processing across multiple workers. Parquet and ORC are inherently splittable. If you remember, we have been talking about the different compression strategies, right? For example, if you are trying to use Snappy with your CSV file, okay, Snappy is a compression algorithm which we are aware about. And if you're trying to use Snappy for your CSV file, which is a row based data, get what? You are not going to attain splittability. So, splittability is nothing but your data must be able to function independently as well. But when you are using Snappy with your CSV file, you cannot split your data, and therefore your format becomes an inefficient strategy. So always ensure that you're using right splittable compression strategies for your file format. And then you have schema evolution. Select formats that support schema evolution to accommodate changes in the data structure without requiring data rewrites. So schema evolution is a common problem all the data engineering projects experience. So you'll be having new file types coming, and you must be able to handle them. So for example, yesterday I might have a file that has only 3 columns, and today I might get a new data file that might have 10 columns. So how am I going to handle it? So there are few strategies, right? You can use Glue crawler and update your Glue schema registry and your Glue data catalog as well, which will be acting as a source for your Glue data. Glue job. Therefore, you can function efficiently. So always ensure that you're going to have an efficient format for your schema evolution, which can be accommodated by the Glue job and can be used to process your data. And then, what are the compression strategies that we must have in place? As I mentioned earlier, have splittable compression. So, what do I mean by splittable compression? So, see, there are different compression strategies, okay? Snappy, gzip, zstandard, and you must know which compression algorithm must be used for a particular file format. If you are using an unmatching algorithm compression algorithm to a file format, you are missing out on your splittability advantage. So always use the right compression strategy like Snappy or a gzip with the right file format. Therefore, by using compression, you will be able to attain splittability, and by which, okay, it is okay you are compressing the data, but what if you need to decompress the data, right? So you must choose the right strategy by which you'll be able to efficiently compress the data and decompress the data and process the data in parallel. Balancing compression ratios and decompression speed. While higher compression ratios reduce storage costs, they can increase decompression time. Choose a codec that offers a good balance for your specific workload. Snappy often provides a good balance between compression and performance. So I understand when you increase your compression. So when you compress your data, what happens? You are saving on the storage cost, which makes sense, and you all need to save the storage. But what if your better compression has resulted in an increasing decompression time? Therefore, it is going to trouble your processing time or your processing performance. So it is kind of relevant, they aren't they? So always ensure you find a balance between the compression and your decompression speed. Choose a codec that offers a good balance for your specific workload. Snappy often provides a good balance between compression and performance. So when you are trying to use a codec, okay, try to have a balance based on your workload. And my personal advice would be always go for a Snappy, because by default you're getting a balance between the compression and performance. A block level compression. Columnar formats like Parquet and ORC often employ block level compression, which works well with splittable compression codecs. So, for your columnar format like Parquet and ORC, try to use a block level compression, okay, by which you will be able to use a when you employ block level compression, all your data is going to be remaining independently. So what do I mean by that? Your data is going to be residing in a block level, okay, each block is separate and they will be remaining separate, and therefore this will work well with splittable compression codecs. By implementing a well defined partitioning strategy and utilizing efficient columnar file format and employing splittable compression, we can significantly optimize data access and processing performance for AWS Glue jobs consuming data from Amazon S3. All right, I hope this would make sense, and I hope this session was very beneficial to you all. And if you have any questions or if you have any doubts, please feel free to put in the comment section. Either me or my team will be able to address them all to you. And before we finish, who are we? We are Data Valley, the fastest growing edtech company of 2025. And we offer support in IT solutions, trainings, and placement as well. And thank you all for joining this sessions. If you like the video, please give a thumbs up and click on the bell icon so that you don't miss out on the any regular updates. And to let you know, we have our data centers or headquarters in multiple locations, which are UK, US, and we have four data centers in Hyderabad as well. So if you are anyone closer to these locations, feel free to reach to our institute and try to help, try to get better in your career. So we are here to help your career development. So feel free to reach out to those numbers, and our colleagues will be more than happier to help you. So I hope this session was very beneficial to you all, and thank you all for joining, and good luck with your data engineering interviews as well. And this is Franklin signing off. And until I see you next time, bye bye. Take care. Good evening.